and welcome back to another episode of Sheddock Customs TV. And in this episode we're going to be back playing with the Rudge, and specifically we're going to be working on the clutch. So one of the decisions I made way back when was to buy an aftermarket clutch as opposed to using the Rudge one. A decision I'm questioning at the moment, but anyway, as you'll see as the video progresses, we're going to get through how we're going to fit this brand new clutch, 2024 clutch, onto a 1939 Rudge. So let's see how we get on. So next part of the plan for the Rudge is the clutch. So this is a Neb Speedway clutch. I've taken all the plates out of it. This centre, which is currently got a couple of trying to think of the word. I'll come back to that. I can't think of the word at the moment, but this spins on a bearing. I need to get this pressed out from the basket. So you've got a circlip around the outside to hold the bearing in. So I'm assuming that the basket's got a shoulder the other side which stops the bearing going through. So I'm going to be able to press on this going down and push it out of the bearing, and then hopefully we can then get that mounted up in however we're going to do it to broach some new splines in there. Splines is the word I was looking for. So I need to put the splines in there which are going to match the original Rudge bearing holder and sleeve. So we're going to put that on a hydraulic press and see how we get on. So I'll bring you back. Right, you find me back in the house having pressed these apart. So this shoulder was basically sitting in that bearing. Now it felt almost, I know using a hydraulic press is different, but it almost felt like I could push that out with my thumbs. It didn't take very much, and I was worried that it might gall this surface and make that damaged, but it didn't, so that's good. So now I can look at turning this in a lathe and getting the right spline centre in that for the Rudge gearbox. So I'll bring you back when I get to that stage. So this is all nice and modern, and I wanted this because I thought it looked pretty and would be a nice little feature on the bike. I know it's not a 1939 clutch, but that's mainly the reason why I'm doing it. And the other part of the puzzle is this, which is, if we can focus in on that, this is the original clutch centre for the Rudge. Let's do that. So if you can see that wear mark, that's where the original ball races ran round on this when it was fitted to the Rudge, and this one is actually scrapped because of that, which won't affect what we're trying to do. So I don't know if you can see inside there, but there is a spline in there which fits on the gearbox shaft, and this outer spline drives the clutch basket. And as you can see, that spline is nothing like the one that's on the clutch basket, or the clutch centre I should say, the clutch centre. So we're going to have a go at modifying that. Now, having done a bit of a measure, this diameter is actually going to mean that this spigot is going to fall off, and then what's going to happen is once we put a spline in here, when you put the sleeve in from this side, this is going to be left sat proud, and this is going to be the diameter which is going to run on the bearing. But this diameter is actually too small at the moment, so we're going to have to make a sleeve up for that. We've got to modify this back edge possibly to give us a bit more clearance. We're not going to be using this thread, so it's going to be quite a drawn out thing, but basically the project at the moment is to change this so it matches that spline. Now I'm very fortunate to have the original engineering drawing from Rudge for that clutch sleeve, which has got the splines on it. So this is an engineering drawing. That is the area of the spline as a diameter. And then over here, pictorially, it shows you what sizes they are, the size of the teeth, the overall dimensions. We know that there's 40 teeth So that's basically 1 every 7 degrees. Now I looked at making the adaptation to the clutch centre myself on a milling machine. I've got a dividing head, but to be honest, I've got to make up a load of tooling, and it's a bit of a case of the juice and the squeeze and which is worth doing. So what I've come up with, or what I've done, is I've talked to an engineering company, and we're looking to get this wire eroded. Now, I'm not going to tell you lots about wire eroding because I'm going to go tomorrow. Well, tomorrow or the next part of the video is going to be me machining off this piece here, because this is going to get in the way when they do the wire eroding. Hopefully they'll let me take some video and show me part of the process. I haven't asked them yet, but let's keep our fingers crossed they won't mind. And hopefully that will get us a description, and if that's not possible, then I'll get a greater knowledge than I've currently got. I've got a reasonable knowledge having spoken to them about what happens, and I'll talk you through the process. But that's the project. So first problem out in the garage, can't get this to meet up with the chuck on the lathe at the moment, so double nutted on the stud. Going to pull these studs out. Still not sure if it's going to work then, but yeah, fingers crossed. Let's get going. So here you can see it's running nice and concentric. I've managed to get it in the lathe, so if I stop that, managed to pick it up on the inside edge of the jaw, which is pretty handy. Couldn't get the studs out, they're locked in, probably Loctited in. I don't really want to take them out anyway. So that shoulder back there is the, let me see, I'll put that a bit bigger. That shoulder back there is what we're going to be machining back to. So all this is coming off. Okay, let's do it. So I'm only going to take small cuts, no point in going mad. I'm going to throw this thing out with the chuck. I've used a ball nose cutter, so it's got a bit of a radius on it, so it's not trying to take it all off with a sharp point, which I think is probably going to be a better move. So I'm just going to work my way through. Slicing and dicing. It's cutting lovely, so I'd imagine this aluminium is really nice material. I would hope it was for the price it was. So I'll keep on doing this and I'll bring you back at the end when it's done. So we're almost done, just got that last little bit to go. Still machining lovely. Fingers crossed. And then it was gone. So I machined it back. Like I said, lovely material. So we'll box this up with the other bits I'm taking, and the next time you see me hopefully we'll be at the wire eroders and we can have a chat with them, or at least show you where it is and drop it off and give them a bit of a shout. Okay, see you then. Okay.
So these are more like solid sparkers.
Right.
So these are, when you first mentioned the project, I thought this is what you meant. So basically what we're doing here is we'll manufacture copper electrodes.
Yeah.
And we'll then use sparkle rods, so like a blind feature into a component. This is a fixture plate, but these are some more examples of like the electrodes that we manufacture.
Oh wow.
So like they've
Got good supply of copper then.
yeah, it's like a blind feature, so that would be sparked into a component.
Right.
Obviously, if the feature's a through feature, we can wire it.
Yeah.
But if it's blind, then it has to be spark eroded because
Okay.
the wire can't pass all the way through. Clever, isn't it? And then these are the wire machines, so this is what your job would have been to cut on. So these are the ones that submerge.
So I'm assuming you fill that up with water. Is this the bit
Yeah.
that's submerged in?
Yeah.
And there's some water. Where's the goldfish go?
Yeah. So this runs on a continuous reel, passes from the top head to the bottom head,
Okay.
and then that goes in through the job, and obviously an electric current runs through it, and
Yeah.
as it cuts.
So is it tethered at this end, or is it literally rolling?
Yeah, it goes through the machine and comes out the back of the machine.
Right.
There's a chipping unit at the back of the machine, so there's a container at the back, and the wire chips as it goes, and it.
Okay. So this is basically what's the word I'm looking for? It's like welding wire. You know, once it's,
Yeah,
you're
yeah.
using it as you go in, and
Yeah, 0.25 diameter.
What is the material?
What of this?
Yeah.
Brass.
Brass.
Yeah.
because it's getting conductive, I'm assuming.
So this is the machine over here that's running at the moment. See the wires going round.
So is this tracking?
That's the path of the wire.
Yeah.
This is doing what you call a destruct program. So they're all little paths, like a cutter
Yeah.
path. It's running around. It's doing multiple little skin
So
paths.
does it go clear as it gets, or is the green what you've got to do, or the green what you've done?
No, the white's what's been done, and the green's what's being done.
Okay.
So it's done all those passes, and it's edging out and edging out and edging out.
Okay. So you don't go in, cut round to the green then, you're literally nibbling away at it.
Yeah, only because of this project, the accuracy requirement. If it was a solid piece of material, we just go straight down the outside profile.
Right.
But on this, they're already bored out. So
Okay.
we're just taking out small.
Not going to see much in there, are we?
No, you can't see that. See the wire. Yeah, yeah.
I guess the design to reduce the that quite a little and something nicer.
So are these all, is this when you talked to me about making a program then? Someone's written all that, or the machine's written it based on a drawing that you put in? Wow. Is this telling you how long it's going to take to finish? Is that the,
Yeah, yeah,
or something?
yeah. Approximately.
Yeah.
These are quite easy for us because they have quite a lot of clearance on them.
Yeah.
Because obviously the nature of it on the boat, it is someone gets quite thin. It just needs slipping there.
Well, it's secure on the centre, isn't it? That's the most comfortable. Yeah.
So what would something like this cost as a machine to buy them?
Over 200,000.
So do you buy them or do you rent them?
We
As
buy
a-
them.
Yeah, okay. Am I allowed to stand on that? Wow. So you're doing the spline on that one, aren't you? That's ginormous. That's ginormous. I've got a couple of blokes lifting it in there when you're doing it. Wow.
Yeah. That's the feature that's going to fit to on the boat.
Yeah. Okay.
Quite
So this is
complex,
just a
isn't it?
test to make sure you've got it right.
Yeah.
Go, no go.
Nice.